Intro ada ni.
Assalamualaikum and very good afternoon. Today we're gonna present about our case study for quality control. My name is Muhammad Daniel bin Muhammad Zain. My number matric is 11 DKM 21F 1019.
And my name is Muhammad Arash bin Adnan, 11 DKM 21F1034.
My name is Muhammad Zikri bin Zulaili. My matric number 11 DKM 21F 1063.
My name is Muhammad Zazul Shamsul, 11 DKM 21F1072.
Okay, so this is our table content.
Introduction to the company and issue. Number 1, introduction to industry background. Example, the manufacturing industry involve the production of goods through various process, often using machinery, labor, and raw material to create tangible product on a large scale. Umicore is a manufacturing company because they are creating for raw material such as raw mineral to chemical product. Example of this company product are CDPF, diesel particle filter and solder product. Issue of company. This stronger customer-centric focus and drive toward future-proof technologies has produced a lot of issues such as customer want to zero defect and often require capability studies. Process must be able, stable and meet specification that vary from customer to customer. Introduction to Statistical Process Control, SPC. SPC is method of measuring and controlling quality by monitoring the manufacturing process. Quality data is collected in the form of product or process measurement or reading from various machine or instrumentation. The data is collected and used to evaluate, monitor and control a process. Example, cause or effect diagram, check sheet, control chart, flow chart, histogram, Pareto chart, scatter diagram. The quality control tool use. Control chart, named after Walter A. Shewhart. This quality improvement tool can help quality ensure professional determine whether or not a process is stable and predictable, making it easy for you to identify factors that might lead to variation of defect. Control chart use a central line to depict an average or mean, as well as an upper and lower line to depict upper and lower control limit based in historical data. Using a control chart can save your organization time and money by predicting process performance, particularly in terms of what your customer organization expect in your final product. This example.
So, the justification for the tools. Companies choose to use control chart for various reasons, primarily to ensure consistent quality, monitor process effectively, and drive continuous improvement. Here are some specific motivations. First, continuous improvement. Control charts are a key tool in the continuous improvement philosophy. like Six Sigma or Lean methodology. 2. Data-driven decision making by providing a visual representation of process performance. Control chart offer a data-driven approach to decision making. Third, early detection of issue. Control chart enable early detection of anomalies or deviation from the norms. This early warning system allow for prompt investigation and intervention. So the question is, in December 2017, as part of a consolidation project, the QC engineer and their workers use QC tool to solve a problem effective in a manufacturing company. This case study highlights to how the use of the quality tool enable quickly business discussion making. The problem, the company had to make product by using the specification provide as 10 cm and 15 cm as length of the alloy. The specification were provided by the customer in their feedback. In the last 5 years, the company had begun making a lot of defective. The measurement rate of defective was at about 20% versus the last year with a percentage of 10%. The company had surfaced as loss of RM 1.5 million losses in the last 5 years due to this defective, accounting to a revenue loss of 40% and about 15%. Client left the company to choose another company that meet their expectation. So the solution, early stage strategy for preventing defect involve measures take right from the beginning of the product development process. Here are some recommended prevent action. The first, design for quality, precise design that provides quality. This involves considering potential weak point, material selection, and manufacturing method that minimize defect. Second, risk assessment and mitigation. Conduct risk assessment during the design phase to identify potential issue. Create plan to mitigate the risk before they become problem during production. The third, prototype and testing. Development prototype early in the design phase and conduct rigorous testing. This help uncover flaw and allow for adjustment before mass production.
Next is data collection and application of result. Data collection. Collecting data for a control chart involves a systematic process to gather information on a specific process or system being monitored. Here's a breakdown of the data collection process for a control chart. Action on outlier or anomalies. If the control chart shows data point outside control limits or unusual pattern, investigate the occurrences. Second, regular review and updates. Continuously update the control chart as new data becomes available. Use the calculated parameter to plot the control chart. The third, plotting data. Use the calculated parameter to plot the control chart. The chart typically involves plotting data points against times or sequence along the control limit. Application for result analysis. Control chart play a vital role in manufacturing industry. With the help of quality control, it helps with process optimization and overall operational efficiency. Here are some specific applications within manufacturing. First, quality assurance. Consistent quality, monitoring critical parameter, dimension, tolerance, and material properties, ensure products meet quality standards consistently. Second, regulatory compliance. Adherence to standards. Control chart provide evidence of adherence to regulatory standards, ensuring compliance with industry regulation and certification. The third, lean manufacturing and Six Sigma. Continuous improvement control chart are integral to Lean and Six Sigma methodologies, facilitating data-driven decision-making and driving continuous improvement initiative. Next is the consequences of not using tools in manufacturing industries. First, lack of process improvement, missed opportunities, failure to identify trends or recurring issues hide opportunities for continuous improvement initiative, ineffective resource management, inventory issue, inaccurate forecasting due to unmonitored variation can result in inventory shortage or excess stock, impacting supply chain efficiency. Third, the predictable equipment downtime, unexpected failure. Failure to predict equipment issue via control chart might result in unexpected downtime, affecting production, schedules, and causing delays. Next, other QC tools that can be used. First, cause and effect diagram. Named for its resemblance to a fishbone, this quality management tool works by defining a quality-related problem on the right-hand side of the diagram. A fishbone diagram's cause and sub-cause are usually grouped into 6 main groups, including measurement, materials, personnel, environment, method, and machines. Third one, SPC tools such as cause and effect diagram and control charts were implemented in the automotive industry. The study in dealt with defects in shocker seal and automotive industry.
Check sheet. Check sheets can be used to collect quantitative or qualitative data. Check sheet collects data in the form of check or tally marks that indicate how many times a particular value has occurred, allowing you to quickly zero in on defects or errors within your process or product, defect patterns, and even causes of specific defects. After identification of the inspection points for data collection, check sheets were developed to collect or mark the defective data for further analysis. Check sheets are forms especially prepared to enable data to be collected simply by checking marks. Flowchart. Quality professionals are often tasked with analyzing and interpreting the behavior of different groups of data to manage quality. The histogram represents frequency distribution of data clearly and concisely amongst different groups of a sample, allowing you to identify areas of improvement quickly and easily within your processes. With a structure like a bar graph, each bar within a histogram represents a group. Histograms were developed based on the data collected through check sheets to display the variation and capability of the process. The frequency of individual defects using histogram for the 4 months of data collection for chassis and trim. Next is Pareto chart. A Pareto chart is a type of chart that combines both a bar and a line graph to display categorical data in descending order. It helps identify the most significant factors that contribute to a particular effect. The bars represent the frequency or size of the categories, arranged in decreasing order, while the line graph shows the cumulative total. It's a tool commonly used in quality control and decision-making processes to prioritize actions for maximum impact. A Pareto chart in quality control is a type of bar graph that helps identify the most significant factors contributing to a problem. The chart arranges issues in descending order to highlight the most critical ones for focused improvement efforts. Conclusion. The 7 QC tools are structured and fundamental instruments that help business, improve their management and production process for achieving enhanced product quality. From assessing and examining the production process, identification of key challenges and problems to controlling the fluctuation present in the product quality and providing solutions for prevention of defects in future. The easy to understand and implement 7 QC tools are very effective. Statistical process control is a vital tool in maintaining quality by monitoring and controlling processes. Its effectiveness lies in providing real-time data to identify variations and take corrective actions, ultimately ensuring consistent and high-quality outputs. So that's all from our group. Thank you.
And the code.